Okay, section 8, our last section of chapter 2, factoring polynomials completely. So it's implied in this title that it is possible to only partially factor something. We've actually dealt with the problem in a previous section where we were able to pull out some common term, factor out some common term from a polynomial, and then continue to factor beyond that point. That would be an example of, multiple steps to factoring. We're going to explore some of that in this section. And also, one thing I'm going to do is I'm going to break down this checklist of things to look for, because it can be overwhelming to sit down to a problem with very little instruction or structure provided, just a bunch of problems saying factor and then just giving you these sentence polynomials. So I'll basically tomorrow give you go through this checklist of what to look for and how what you see will dictate what kind of strategy you'll use to factor it. Because as long as you can identify the correct strategy, then it's just a matter of using that structure. Okay, so today we're going to focus on a single technique up here, grouping. And this will be unique to 4-term polynomials. Okay, so these will be pretty distinctive in this section's assignment as well as on your chapter 4 test. When you come across 4-term polynomials, like what we're seeing right here, you're going to be using this technique of grouping. All right, and I'll go through it. This is actually something we've used in another strategy in our X method, namely with the table, pulling out common factors. I'll reference that more specifically tomorrow and kind of tie a bow on it for connecting those dots. But for right now, we're just going to learn the technique of grouping. So let me just go ahead and jump right into these examples. Again, these notes are uploaded onto Google Classroom. So our first example for today, we're given these very familiar instructions at the very beginning, telling us to factor some given polynomial. So again, what does factoring mean? It means that I'm doing the inverse of distribution. And just reminding us, like, distribution is something we've been doing since middle school, right? Distribution involves this multiplying into some parentheses. So factoring undoes that. Basically, it gives me some polynomial, some result, and then moves it back into parentheses form. So that's essentially what we're going to be doing here when it asks us to factor. And then we're given our polynomial phrase. In this case, we're going to see something a little bit longer than what we've experienced in the past. So x cubed plus 3x squared plus 2x and plus 6. Almost ran out of room. Okay. So here in this problem, we're given our polynomial. It's a slightly longer polynomial than what we have dealt with in the most recent sections and stuff. But still, we have this polynomial and we're asked to factor. So as with other sections, there is one step I need to always do first. I need to check to see if there's a common factor into each of these terms. This is called finding a greatest common factor. Okay, basically, is there something shared in common with all the terms in my polynomial sentence? And I have 4 to choose from here in this example. So as I've said before, kind of deal with your numbers first and then with your letters, your variables. As I can see here, technically there is a coefficient in this case. It's just technically a 1. We just don't bother writing it. So if I pay attention to just the coefficients, I'd be comparing 1, 3, 2, and 6. Well, because I'm dealing with a 1, the only thing in common with all 4 coefficients would just be the number 1, and that's not worth factoring out, so I can move on from there. Next would be my variables, my letters. So I have x cubed, x squared, x, and then no x. And because this term doesn't have an x, there's no variable in common between all 4 terms, so there's no term I can pull out for that either. So I'm stuck with what I have right now, okay? So my job now is to factor. So here, I'm just going to jump right into the technique. Essentially, what I'm going to be doing is I'm going to be grouping this 4-term polynomial into 2 groups of 2. I'm going to group this into 2 groups of 2. So this only really works for 4-term polynomials or greater. For the record, in our class, you're only going to deal with a maximum of 4 terms. Okay, so this is about as long a polynomial as you will see. And so in our case, once you see a 4-term polynomial, this is the only case where you're going to be using this grouping strategy. Okay, so I'm going to group these 2 terms and these 2 terms. Essentially not doing anything yet other than just organizing these guys together. So these first two terms, x cubed and 3x squared, and then my next two terms being positive 2x and 6. Okay. So as you can see, I've done nothing other than really just color coordinate this and add in these parentheses. Now, parentheses don't really do anything. They just organize things. So in this case, all I've done is it's the same exact polynomial as I started with. I've just grouped them into two specific groups. Okay, so let me kind of give you a spoiler alert right now for what we're attempting to do. Okay, by grouping these into two separate groups, here's my purpose. Here's what I'm trying to do. Each of these groups, I'm going to pull out common terms, common factors, because once I've grouped these two, now you can see here, I do have stuff in common with just these two terms. I do have stuff in common with just these two terms. Okay, and so what I'll be able to do is I'll be able to pull out common factors from each of these groups that are unique to each of these groups. This pink group over here and this blue group over here. My goal here is to, once I pull out these common factors, I'm going to be left over with stuff inside the parentheses, the stuff that's left over after pulling out these common factors. What I want to happen is I want whatever's left over in this blue group, once I pull out the common factors, whatever's left over here, I want to match whatever's left over here in this pink group once I've pulled out those common factors. Because if both of these parentheses end up matching each other, now I have another common term. And you'll see what happens when that happens. So for right now, suffice it to say, I've set up these two groups. Again, this can only happen with 4-term polynomials because I'd have a group of 2 and a group of 2. All right, so in each of these groups, I'm going to pull out common factors. So let's focus on the blue group right now. Again, focusing on coefficients or numbers first. Technically, there is a coefficient here. It's just 1. Okay, so 1 and 3, the only thing in common is 1, and that's not worth pulling out, so I can ignore that. But now let me focus on the letters, my variables. I have x cubed, or 3 x's multiplied by each other, and then I have 2 x's multiplied by each other, x squared. So what's in common with each of these terms is 2 x's. Both of these terms have 2 x's. So the way I can pull that out is by factoring out an x squared. Okay, so here's again where I'll remind you what specifically factoring does. Okay, so what's happened here is I found a common term inside of this parentheses and I factored it out. Okay, so to remind us how something does that, again, if whatever's left over in here, what should be able to happen is I should be able to distribute this object back into whatever's in this parentheses to get right back where I started. Okay, that's how math works. If I do an action, I should be able to undo that action. All right, and so distribution, if I were to multiply this x squared back in, is done by multiplication. So when I factor something out, okay, it's not subtraction, it's not taking something away, it's dividing something out, because division undoes the multiplication that would happen in a distribution case. So what I'm doing with this x squared is I'm dividing it out of each of these terms. So this x cubed, when I divide out x squared, I'm left over with just a single x. And as you can see, if I were to multiply this x squared times x, I'd get right back to x cubed. Now, the second term, if I were to divide x squared out of positive 3x squared, I'm left with just positive 3. Again, if I were to distribute this x squared into that positive 3, I'd get right back there. Okay, so what we've done, again, is we've grouped into this blue group right here and then pulled out this common factor. So now I have what I used to have was a binomial that now I have a monomial technically. I have this object times this object. This object happens to be a parentheses, but now I have a straight multiplication problem here. And I'm going to do the same thing over here with this pink group. So in this one, focusing on the coefficients first, I have a 2 and a 6. Well, they both share a 2 in common, right? So I can pull out a positive 2. And then can I pull out any letters? Well, this term has an x, but this one does not. So there's no letter in common to pull out. So this is the greatest factor that I can pull out of the pink group. And then again, what's left over, I figure that out by dividing out this common factor from each term. And in this case, if I were to divide 2 out of 2x, I'm left over with just x. And then if I were to take that same 2 and divide it out of the positive 6, I get positive 3. And deja vu, our whole purpose, again, I gave the spoiler alert before, what we ultimately want is we want this parentheses to match this parentheses. And there's a reason why. But I'll get to that in a second. But let me break down what we've done first. Again, I started with a 4-term polynomial. I broke it up into 2 groups of 2. And you're going to see in the next example that I can also rearrange this polynomial as needed so that I get groups of things that I can pull common factors out of. I didn't have to rearrange anything in this problem, but we'll see in the next problem that we will. Okay, but once I have my 2 groups, what I'm going to be doing is pulling out common factors, dividing them out of whatever's left over, with the purpose of matching these 2 parentheses. Because here's what has just happened. Before, I had a 4 polynomial term, okay, a 4-term polynomial. By grouping these together and then factoring stuff out, now this technically right here, this blue group, is now a monomial because I have the multiplication between this object x squared and a parentheses. That's a monomial. That's its own object. Same thing happened here. By factoring out this common factor, this is now a monomial. This is now, this pink group is a multiplication between positive 2 and this parentheses. Why did that matter? Because now in this now binomial, blue object, pink object, they share something in common. They share this parentheses. Each of these terms have an object in common, this x plus 3. That object happens to be a parentheses, but even so, it's an object in common between both of these objects, being the blue object and the pink object. Why does that matter? Because now I can factor that out. In other words, I can factor out this parentheses, this x plus 3, which is technically multiplied by multiple things here. And what I'll be left over with, again, when I factor something out, whether that something is as simple as an x squared or a 2, or if I'm pulling out something as complex as a parentheses, I'm still dividing it out. So in this blue object right here, when I divide out this parentheses, I'm left over with just x squared. And the same thing goes over here. When I take this object, this pink object, and I divide out the parentheses, I'm left over with just positive 2. This can only be done if my parentheses match. If they didn't match, they wouldn't have anything in common. So because both of my parentheses here had this x plus 3, I was able to factor out that parentheses, and then I'm left over with those objects. And what we've just done in each of these steps is we've basically reduced the number of terms in this polynomial. We started with 4. By grouping them into these 2 groups and factoring stuff out, we went from 4 terms into 2 terms. Blue object, pink object. Again, because I have multiplication here. And then by factoring out this parentheses, right? By factoring out this parentheses out in front and multiplying it by whatever was left over, now this is technically a monomial. I have multiplication here between 2 objects, 2 parentheses. So really quickly, this would be my final answer. Technically, we'll talk about this tomorrow, but I would check to see if this guy can factor any further. This one does not. I'll go ahead and spoil that. But just to kind of see what we've done, what I should be able to do to undo it would be to distribute and collect like terms here between these 2, this multiplication between 2 parentheses here to get right back where I started at the beginning. So just doing that quickly, if I were to take this x and multiply it through this parentheses, so x times x squared, I'd get x cubed. Take that same x times positive 2, I'd get positive 2x. Done with the x, and I move on to the positive 3. Positive 3 times the x squared gives me 3x squared. Almost done with this. Now I take the positive 3 lastly and multiply it by the positive 2, giving me 6. And this technically is what I started with at the beginning. It's just that these 2 objects would be swapped. And when I have a string of addition, it doesn't matter which object goes where. So I can actually swap these 2 and rewrite this as x cubed plus 3x squared plus 2x plus 6. And that's really just so that I can confirm it is exactly what I began with at the beginning. Okay. Again, all that's demonstrating is that my starting polynomial, if I factor it down to this value, I can also undo that to get right back to this polynomial. Okay, one action undoes another. All right, let's do one more example. We're going to be asked to do the same thing, to factor. That will be the simple instruction at the beginning, but then we're given this polynomial. We're given x squared plus y plus x plus xy. All right, so this one may seem a little more intimidating because first off, I don't have any coefficients. There are no like numbers I'm dealing with. I only have two variables. Okay. The second thing is similar to the last problem in that I have a 4-term polynomial. And as soon as I see this 4-term polynomial, my immediate reaction will be to use grouping. Now, here's where it will be slightly different than the last problem, because again, I have to keep my goal in mind with why I'm grouping. Okay, the whole reason I might group things together is because I'm looking for a common term. So for instance, if I were to group these first two terms together, I would be looking for a common factor to pull out of that group. But I run into a problem. There is no common factor between these two pieces. Okay, there's no coefficients to concern myself with. Technically, they both do have a coefficient. The coefficients are both just 1, but I can't factor that out without doing anything, or that will do anything. And then as far as the letters go, I have an x squared and a y. Well, they don't have anything in common, so this would be stuck. And so I wouldn't be able to use grouping with that pair. But kind of using a similar concept I did just at the end of that last problem, I can rearrange this polynomial in any whichever way I want. I can move stuff to the end, the beginning, middle, it does not matter. As long as I keep the correct sign with each of those objects, it doesn't matter where I move them in the sentence. So here's what I'm going to do. I'm going to take these two objects and swap them. And here's why. I'm going to swap these guys because by moving this x over here and grouping it with my x squared, the x and the x squared will have something in common, x, right? By moving this y over here, my y and xy will have something in common. They'll have y, right? So x squared and x would be able to have something in common. Y and xy will have something in common. I'll be able to actually pull out common factors. So essentially what I'll be doing is this. I'm just going to rearrange this very same polynomial. Again, I'm going to swap these two guys. So instead of putting plus y, I'm going to put plus x and then plus y. Again, just taking those two terms and swapping them. Nothing changed with value. It's just a rearrangement. So these two polynomials are exactly the same. This is just a rearrangement of what they are. And the reason why I did this is because now I'm going to group each of these pairs and have something that I can actually factor out. So I'm going to group these guys and I'm going to group these guys. Again, nothing has really changed so far. Those parentheses aren't doing anything yet. All it's doing is just organizing stuff. It's letting me know where I'm going to be looking for common factors. So in my first group here, my blue group, right? In my first group here, I'm looking for common factors. No coefficients to worry with. So I have two x's and an x. I'll be able to pull out the common factor of a single x. And when I take this x out, I'm doing it with division. So x squared divided by x, I'm left over with a single x. This positive x, when I divide x out, common mistake. A lot of people think there would be like a 0 here or nothing there. That's not true, because when I take x and divide it by x for my factor, I actually get 1. I'm never going to get something to disappear or go away because I'm not subtracting. This isn't subtraction, this is division. Okay, that's an important thing to understand. That's why I get to 1 here. And then over here, again, looking for a common term. My common term between these two guys is a positive y. So I'm going to factor out a positive y, and I'm going to be left over with some stuff. Here's that stuff. I'm going to pull this y out with division. So y divided by y, here I'm going to get positive 1. And then this positive xy divided by y is going to give me just a positive x. Okay, so again, my goal here was to get these parentheses to match. But here's my problem. X plus 1, 1 plus x, you might think those don't match, but they actually do. Because it doesn't matter which one I added first. As long as I have the correct sign in front of both of these, then it's the same. So for instance, 3 plus 5 is the same thing as 5 plus 3. X plus 1 is the same thing as 1 plus x. So in other words, I can factor this parentheses out because it's in common in both these terms. So if I factor out this x plus 1, I'm taking this away by division. So dividing out this parentheses, I'm left over with just the x. If I were to take that x plus 1, 1 plus x, it actually doesn't matter. But if I factor out this parentheses, I'm left over with just plus y. And this is my final factored version right here. If I want to check my work, if I wasn't convinced, I could use distribution and collection of like terms to multiply these two polynomials together to get right back where I started. There we go. All right, I'm going to end recording.